Hello, my name is Tracy Purdy, and I had problem 21 from section 5.4. These are the first three given equations that it gives you. X prime sub 1 equals 5x sub 1 minus 6x sub 3. X prime sub 2 equals 2x sub 1 minus x sub 2 minus 2x sub 3. And x prime sub 3 equals 4x sub 1 minus 2x sub 2 minus 4x sub 3. So then I converted this into a matrice. So then I used my characteristic equation and I multiplied my lambda throughout, since that's such an easy step. So then I subtracted these two matrices from each other and I get 5 minus lambda, 0, negative 6, 2, negative 1 minus lambda, negative 2, 4, negative 2, and negative 4 minus lambda. So then I needed to find my determinant. And since I didn't have enough room on one line, these two lines right here are my one big equation. And the first thing I did was just cancel out my 0, so I canceled these two out. So then I get the quantity of negative 5 minus 4 lambda plus lambda squared times the quantity of negative 4 minus lambda plus 24 minus 24 plus 24 lambda plus 20 minus 4 lambda. So then I just distributed everything out, and then next I canceled out my like terms, so my 4 lambda squareds cancel, so then I simplify this equation more, distribute my negative through, and my 44s cancel, so I'm left with lambda minus lambda cubed equals 0, so then I factor out a lambda, and then I will get 3 lambdas. I get it to equal 0, 1, and negative 1. So first I plugged in 0 for lambda and I get 5, 0, negative 6, 2, negative 1, negative 2, 4, negative 2, 4 matrice. So then I used my calculator that Melissa showed us, that RREF, and I end up getting this matrice. So then I get A equals 6/5 C and B equals 2/5 C. Well, I mean, these originally equaled 0 and then I added them to both sides. And so then for my first one I get the matrice of 6, 2, 5, and the reason I chose those was because when I have C equal 5, it'll cancel out my denominator, so it'll make A and B whole numbers, so it'll make it easier just to write for my equation. So then when lambda equals 1, I get 4, 0, negative 6, 2, negative 2, negative 2, 4, negative 2, negative 5. Then once again I plug that into my calculator and I end up getting A equals 3/2 C, B equals 1/2 C. And I did the same thing as I did before here. I just made my C equal 2, so then I'll get whole numbers here. So then my A equals 3 and my B equal 1. Then finally, I plugged in negative 1 for lambda, and I get 6, 0, negative 6, 2, 0, negative 2, 4, negative 2, negative 3. And then I plugged that into my calculator, and I end up getting A equals C and B equals 1/2 C. Here, just being, when C equals 2, that'll just make B equal 1 and A equals C. So just once again to keep everything as whole numbers. So then it asked you to use the eigenvalue method to find the general solution, and that method is x of t equals c1 x1 of t plus c2 x2 of t, and it tells you in equation 10 in the book that x1 of t equals v1 e to the lambda 1 t. So I have my v1, my v2, and my v3 here. And so I just plugged it into that final equation. So I have C1 times my V1, and my lambda was 0, so e to the 0 is 1, so you don't need to write anything. So then I have C2 times my V2, and my lambda was 1, so you get e to the t, excuse me. So then the last one is C3 times my V3 matrice, and my lambda was negative 1, so I get e to the negative 2. So then next I just multiplied my C1, my C2, and my C3 by my matrices, and I end up getting x of 1 equals 6C1 plus 3C2 e to the t plus 2C3 e to the negative t. My x sub 2 equals 2c1 plus c2 e to the t plus c3 e to the negative t, and my x sub 3 equals 5c1 plus 2 c2 e to the t plus 2 c3 e to the negative t. And that was my general solution. Thank you.